Welcome to Spring LIB.
In this problem, we have been given that there is a block of mass 30 kilogram which is lying on the surface that provides the static friction coefficient as 0.45 and kinetic friction coefficient as 0.25. So first we need to determine the minimum force that must be applied to this block so that this block starts moving. So in that case, let's figure out the static friction and the kinetic friction. So both these frictions can be obtained by multiplying their corresponding coefficients and the weight, which will be just the normal reaction in the case if we just observe the free body diagram. So when we multiply them together, we observe that the static friction comes out to be approximately, so let's multiply 0.45 with the mass, that's 30, and multiply that with the acceleration due to gravity, that's 9.8. So we get the static friction as 132.435 newtons. And similarly, we get the kinetic friction, and that comes out to be 0.25 times 30 times 9.81, which is 73.575 newtons. So in the first case, we need to determine the minimum force that must be supplied so that the block starts moving. So we are talking about the initiation of the movement. So the force should be sufficient enough to overcome the static friction at least. So the minimum force that must be required or that must be supplied here to this block so that it starts moving, that is 132.435 newtons. And in the next case, we need to determine the acceleration with which this block starts moving if a force of 95 Newton is applied. So since we are talking about the movement, that means the force of friction will be the kinetic friction, and the net force here will be 95 minus the kinetic friction, which is 73.575, and we divide with the total mass to get the acceleration. And the acceleration comes out to be, let's simplify, let's subtract 73.575 from 95 and divide it by 30, and we get the acceleration here as 0.714 meter per second square. So that's the acceleration of this block.